What is the molecular formula for alum? Nothing but the KAlSO4 twice 12H2O. So what is that 12H2O? Nothing but the alum is available into the both form. First one is nothing but the hydrous as well as the anhydrous form. When it comes the anhydrous form, just you have to write down the plain molecular formula, nothing but the KAlSO4 twice. K nothing but the potassium, Al is nothing but the aluminium, and the sulfate SO4 twice. So what is the molecular formula for the alum? Nothing but the potassium aluminium sulfate. What is the synonym for the alum? Nothing but the potassium aluminium sulfate. See, in exam they will ask the question, explain about the potassium aluminium sulfate. Otherwise write the uses as well as the chemical properties of the potassium aluminium sulfate. That means you have to write about the alum. So physical properties nothing but the what is the nature? Nature is the crystallines. They are available into the crystal form. So color is nothing but the colorless, nothing but the white crystal. See here, I shown you. So what is the color? Color is the colorless, nothing but the transparent crystals. And taste is the astringent as well as the sweet taste. It having a sweet astringents, nothing but the god turat. It having a sweet astringent taste. And solubility, mainly it is soluble into the water. It is also soluble into the some acidic solution. Mainly it is soluble into the water. Already I told most hydrous drugs are soluble into the water. So that potassium aluminium sulfate is available into the hydrous as well as the anhydrous form. So it is soluble into the water as well as it is also soluble into the various acidic solution. It is mainly insoluble into the alcohol. So this is the physical properties of the alum, nothing but the potassium aluminium sulfate. What are the physical property? First one is the molecular formula. What is the molecular formula? KAlSO4 twice. So this is the molecular formula for the potassium aluminium sulfate. Next one is the synonym. What is the synonym? It is also called as a potassium aluminium sulfate. Molecular weight, just to calculate, KAlSO4 twice, nothing but the K is the 39, aluminium, just to take, sulfur is the 32, oxygen is the 64. Calculate whatever you will get, that is the weight of the potassium aluminium sulfate. Then nature is the crystalline. Color is the colorless. It is available into the crystal form. So colorless transparent crystal. Odor is the odorless. Taste is the sweet astringent taste. And solubility, mainly soluble into the water, and it is also soluble into the various acidic solution, and it is insoluble into the alcohol. They are available into the both form, hydrous as well as the anhydrous form. Now we have to see the chemical properties of the alum. So what is the chemical property? Nothing but the here dehydrations will carry out. So on the dehydration, so what you will get, the KAlSO4 twice 12H2O. When you have to carry out the hydrolysis, nothing but the dehydrations, carry out the process. So what you will get? You will get the anhydrous alum. You have to give the heat under high temperature. You have to provide the heat. Then what they will give? They will give the anhydrous form of the alum. Nothing but the hydrolysis process you have to carry out. So nothing but the dehydration. Next one is the method of preparations. How to prepare the potash alum? So how to prepare the potash alum? See, potash alum is obtained by adding a concentrated solution of potassium sulfate in a hot solution of an aluminium sulfate. How to prepare? Just you take the concentrated solution. What is mean by the concentration? Without dilution, nothing but the pure form of the solution. You should not dilute, nothing but the concentrated solution of potassium sulfate you have to take, and in that you have to add the hot solution of the aluminium sulfate. Equimolar proportion mante. Equimolar, what is the equimolar proportion? Equimolecular proportion, nothing but the, if you are taking the potash alum 20 ml, you have to add the 20 ml aluminium sulfate. So whatever you are taking equimolecular proportions, you have to add the ingredients to make the potash alum. So how to, just you take the 20 ml of potassium sulfate, then you add the 20 ml of aluminum sulfate. But how to take, you have to take the concentrated solution of potassium sulfate, nothing but the pure form of the, without dilution. You have to take the potassium sulfate, and in that you have to add the hot solution, hot form of the solutions you have to add, nothing but the aluminum sulfate you have to add. So just you take the concentrated solution of the potassium sulfate, and in that you had add the hot solution of aluminum sulfate, and then mix it. After mixing, you will get the concentrated solution. What is the concentrated? Nothing but the thick semi solid. So there is a water content or any solvent is the less, so you will get the thick content, thick solution of the given mixture. Just you have to cool, and what you have to do, then you will get the octahedral crystal. So that product you will get into the crystal form. Which types of the crystals you will get? You will get nothing but the octahedral crystal. So already I told, in chemistry we have to carry out the practical, some minor preparations we have to carry. How to prepare? So how to prepare this alum? Nothing but just you take the concentrated, so without dilution, nothing but the pure form of the potassium sulfate. In that you have to add the hot solution of the aluminum sulfate, nothing but the equimolecular. If you are taking the 20 ml, then you have to add the 20 ml aluminum sulfate. Then what you have to do, you have to mix properly. After mixing, what you will get, you will get the concentrated solution, nothing but the thick form of the solutions you will get. Just you have to cool on a ice bath. After cooling on a ice bath, what you will get, the, you will get the octahedral types of the crystals, you will get the crystal. So you have to, which types of the crystals you are getting? Nothing but the octahedral types of the crystals in cognosy. So there are the types of the crystals are there: prismatic crystals, then octahedral, then needle like crystals. So there are various types of the crystals in cognosy that teacher will learn you. So what is the crystals and what are the types of the crystals? Here which types of the crystals are you are getting? Nothing but the octahedral types of the crystals you will get. So whenever you will get the concentrated solution, just you have to cool on a ice bath. After that you have to filter by using the filter paper, and what you will get, you will get the upper side residue, nothing but your products. So that product is nothing but the alum. So here reaction I gave. So when sulfate, potassium sulfate reacts with the aluminum sulfate, then what you will get? You will get the potassium aluminum sulfate, nothing but the alum. This is the method of preparation of the potassium aluminum sulfate. Next one is the uses. What are the uses of the potassium aluminum sulfate? So astringent, it is mainly used as a astringents. Astringents is nothing but the protein precipitation, nothing but the constrictions as well as the shrinkage of the tissue. For the treatment, that the it act as a astringent agent. Next one is that it is also used as a pharmaceutical purpose, nothing but it act as a pharmaceutical aid. Then it act as a styptic for the minor cuts and the abrasions. So what is the styptic? Nothing but that causes the contraction of the body tissues, constriction of the body tissues. It act as a styptic for the minor cuts and the abrasions. म्हणजेच काय, तुमच्या जखमा किंवा तुमचा damaged skin part, here it act as a styptic, nothing but it causes the contraction of the body tissues. How it contract? By supplying the, by decreasing the supply of the blood flow, it act as a contraction of the body tissues and on the cuts as well as the abrasions. And preparation of the diphtheria and the tetanus toxoids, it is also used for the preparation of the vaccines. Which types of the vaccines? Diphtheria vaccine as well as the tetanus vaccine. Mainly these potassium alum is used for the potash alum. It is also called as a potash alum, plain alum, as well as the potassium aluminum sulfate. So this potash alum is mainly used for the preparation of the vaccine, nothing but the diphtheria vaccine as well as the tetanus vaccine. So next one is the storage. How to store? You have to store into the well closed container. So you have to store into the tightly well closed container from the avoiding the degradation of the product. This is the all about the potash alum. It is also called as alum. Synonyms are the alum, potash alum, as well as the potassium aluminum sulfate. Chemical property is nothing but the, on the dehydration process, you will get the anhydrous form of the potash alum. Uses mainly used as astringents, pharmaceutical aid, it acts as a styptic as well as the preparation of the diphtheria vaccine and the tetanus vaccine. You have to store into the well closed container. This is all about the astringents. What is astringents? Mainly it comes under the topical agents. What is the topical agents? Which are applied externally on your body parts, nothing but the topical agents. Then types of the classification of the topical agents. Then what is mean by the astringents? Nothing but the, it is a compound which act as a shrinkage as well as the constriction of the body tissues, nothing but the precipitation of the protein, and it act as a protective layer on your body surface, and it also reduces the wrinkleness. This is all about the astringents, type of the astringents. Next one is the how to bind the protein, nothing but the mechanism of the protein precipitation. Then zinc sulfate, mainly two inorganic agents are used. The first one is the zinc sulfate and next one is the potash alum. So molecular formula, synonym of the zinc sulfate, then solubility, then preparation method, then uses as well as the storage. Alum also same molecular formula, synonym, physical chemical properties, preparation method and the uses as well as the storage. Here our astringent chapter is over. All of you understand?
Yes, ma'am.
Okay, here our chapter is finished.